Throughout human history, between 1 and 2 billion people have died in wars, according to various estimates. This includes all wars, all eras, from bronze swords to nuclear bombs. Mosquitoes have killed more. Estimates most often cite around 52 billion. Half of all people who have ever died on Earth may have been killed by a mosquito. The figure is controversial, the methodology complex, but the order of tens of billions is rarely disputed. And even if we take the most conservative estimates, the mosquito still remains the deadliest animal in the history of our species. Not snakes, not sharks, not wolves. A 2 milligram insect with transparent wings. But today I don't want to talk about malaria, or rather, not only about malaria. I want to talk about the mechanism itself, about what happens between you and the mosquito the moment it lands on your hand. Because when you start to understand the details, it turns out that this process is more complex than it seems. Much more complex. Let's start with choice. You've probably noticed that in any group, there's one person who's devoured by mosquitoes and another who's barely touched. This isn't a myth or a subjective feeling. It's a reproducible result. Studies show that about 20% of people are significantly more attractive to mosquitoes than others. The question is, why? For a long time, it was thought that blood type was the culinary factor. Blood type 1 is the tastiest, blood type 2 the least attractive. There is indeed a study on this topic. It was conducted by Japanese scientists in 2004, but the sample size was small, and the results haven't been replicated very convincingly since. So maybe blood type plays a role, and maybe it doesn't. What definitely plays a role is carbon dioxide. Mosquitoes can sense CO2 from up to 50 meters away. They have receptors on their palps that are tuned specifically to carbon dioxide. Every breath you exhale is a signal. Larger people exhale more CO2. Pregnant women exhale approximately 21% more than non-pregnant women. People also breathe more after physical activity. Children, as a rule, exhale less. Incidentally, this is one of the reasons why adults are bitten more often than children. Not the only one, but one of them. When a mosquito flies closer, within 10-15 meters, the second channel switches on. Heat. Mosquitoes don't see in the infrared range, but they have thermoreceptors on their antennae, and they can distinguish temperature differences of a fraction of a degree. They move toward a warmer object. So, if you stand next to someone after a run who has been sitting in a chair for the last hour, the mosquito is more likely to fly toward you. You're warmer. You exhale more carbon dioxide. You're a beacon. The third channel is smell. And this is where the most difficult part begins, because human odor is not a single component. It's a mixture of more than 400 volatile compounds, and the composition of this mixture is different for everyone. Lactic acid, ammonia, fatty acids, acetone. All of this is secreted by the skin, and mosquitoes react to specific components. In 2011, a team from Wageningen University showed that people favored by mosquitoes aren't distinguished by a single delicious scent, but rather by a reduced diversity of skin microflora. So it's not that you have something attractive, it's that you lack something repellent. When I read this, it took me a while to wrap my head around it. The bacteria on your skin, their species composition, and their proportions determine how attractive you are to a mosquito. This means that two genetically close people, even twins, can attract mosquitoes in completely different ways if their skin microflora differs. And it always does. Okay, the mosquito has found you and landed. What next? What happens next is what most people imagine as a prick, as if the mosquito were a syringe with wings. One needle, one puncture. Blood flows. This is the wrong picture. It's so wrong that when scientists from the Institut Pasteur captured the process on video in 2013 using fluorescence microscopy directly through the skin of a living mouse, it changed the perception even within the professional community. Here's what's really going on. What we call a mosquito's proboscis isn't a single needle. It's a bundle of 6 stylets enclosed in a soft sheath, the labium. When a mosquito lands on the skin, the labium doesn't penetrate. It bends and remains on the outside as a guide, while 6 elements extend inward. 2 of them, the mandibles, have teeth and act like a saw, cutting through the skin. 2 more, the maxillae, push the tissue apart. One, the hypopharynx, delivers saliva to the wound, and one, the labrum, is the actual channel through which blood flows. 6 instruments working simultaneously. But the most interesting thing in that video from the Institut Pasteur isn't the stylets themselves, but how the tip of the proboscis behaves under the skin. It doesn't go straight ahead. It searches, it moves, bends, sometimes almost turns around, feeling for a capillary. This isn't a passive insertion. It's an active search within the tissue, which can last from a few seconds to several minutes. The tip of the proboscis is flexible, and it literally explores the space under the skin until it encounters a vessel. I remember watching this video for the first time. It looks, and I don't know how to say it more neutrally, like something with a will of its own. Of course, there's no will there. There are mechanics and chemoreception, but the impression is strong. When a capillary is found, saliva begins to flow. And here, as with a tick, saliva isn't just a lubricant. It contains an anticoagulant, which prevents the blood from clotting at the puncture site. It contains a vasodilator, a substance that dilates the vessel so that the blood flows more freely. It contains an anesthetic, so you usually don't feel the bite itself. The itching starts later, sometimes after minutes, sometimes after hours. And this isn't the mosquito's effect, it's your immune response. Histamine. Your body reacts to the proteins in the mosquito's saliva as if it were an invasion. Swelling, redness, itching. All of this is your body doing, trying to deal with the foreign molecules the mosquito left in the wound. By the way, this is why children who are bitten for the first time often don't scratch. Their immune system isn't yet familiar with the proteins in mosquito saliva and doesn't trigger a reaction. Itching is a learned response. It appears after several bites, when the body begins to recognize the saliva as a threat. But in people who are bitten very frequently, every day for decades, the reaction sometimes fades. The immune system seems to stop paying attention. This is called desensitization. Now about diseases, because without them, a discussion about mosquitoes would be incomplete. Malaria. Plasmodium is neither a virus nor a bacteria. This is a protist, a single-celled parasite of the genus Plasmodium. The most deadly species is Plasmodium falciparum. It is transmitted by mosquitoes of the genus Anopheles, not by all mosquitoes, but by a specific genus. There are about 30,500 species of mosquitoes in the world, and only a few dozen species of the genus Anopheles effectively transmit malaria. In 2022, according to the WHO, about 249 million people fell ill with malaria. 608,000 died. Most of them were children under 5 in sub-Saharan Africa. About 1 child every minute. This number is decreasing. Slowly but decreasing. In 2000, almost twice as many died. There is progress. It is just not fast enough. In addition to malaria, there are dengue fever, yellow fever, Zika virus, chikungunya, lymphatic filariasis, and Japanese encephalitis. The list is long, and they are carried by different species of mosquitoes. DMG ica is primarily Aedes aegypti and Aedes albopictus, and Japanese encephalitis, Culex triteniorhynchus. Each virus has its own vector, its own geography, and its own dynamics. Sometimes I hear the question, maybe we should just exterminate all mosquitoes? Technically, this has become theoretically possible for the first time. There is gene drive technology, a genetic modification that spreads through a population, and can, for example, make all females sterile. This has already worked in laboratories. Populations of the Gambian Anopheles were completely suppressed in closed environments, but no one has yet dared to release it into the wild. And not only out of caution. There is a real question. What will happen to ecosystems? Mosquito larvae feed on fish, dragonflies, and aquatic beetles. Adult mosquitoes feed on birds, bats, and dragonflies. In the Arctic tundra, mosquitoes make up a significant portion of the flying insect biomass and pollinate plants. Yes, mosquitoes pollinate. Only females feed on blood, and only when they need protein to hatch their eggs. The rest of the time, both females and males feed on nectar. They are pollinators. Not the most effective, but in the tundra, where there are few competitors, they are significant. Removing mosquitoes means removing a link that underlies dozens of food chains. Some ecologists believe that the ecosystem will be rebuilt, while others believe the consequences are unpredictable. There is no definitive answer, and perhaps this is a case where the lack of a definitive answer is itself an answer. Don't touch until you fully understand. One more thing I think is important. A mosquito lives from 2 weeks to 2 months, depending on the species and conditions. A female lays 1 to 5 clutches, in her lifetime, each containing 100 to 300 eggs. She needs a blood meal each time, before laying. It's not greed or aggression, it's reproductive necessity. Without blood, there's no protein. Without protein, there are no eggs. Without eggs, there's no next generation. A female mosquito drinks your blood for exactly the same reason you eat your dinner. She needs to raise her offspring. Only you're not injecting saliva into anyone's skin. Do you know what really struck me when I was researching this? Not the mortality rate, not the scale, but the sound. A mosquito's squeak isn't a voice. A mosquito doesn't squeak with its mouth. It's the sound of its wings. They beat 400 to 800 times per second, and the frequency of their wings differs between males and females. Males beat faster, at a higher frequency, and when a male and female are close, they adjust their wing beats to each other, synchronizing them. Not to the same frequency, but to a harmonic one. Their frequencies converge on a common overtone. This was demonstrated in a 2009 study by Cornell University. Two mosquitoes in mid-air adjust their wings to create a harmonious, almost physical sound. It's their way of saying, "I'm here, I hear you. I'm with you." It's strange to think about this when you're slapping your cheek at 3 a.m. If you want more stories like this on this channel, please subscribe, it helps.